Welcome to the Deep Sleep Science Channel. Tonight, we're settling in with the quiet and remarkable world of camels, animals shaped by heat, distance, and survival in ways that are far more fascinating than they first appear. Before you drift off, gently like, subscribe, or leave a soft comment if you enjoy calm science like this. And now let's begin with one of the most surprising truths about camels. Their humps do not store water at all, but fat, which serves as an energy reserve when food is scarce. This is one of the most common misunderstandings about camels. The hump acts more like a storage pantry than a water tank. And by keeping much of that fat concentrated in one place, the camel avoids spreading insulation all over its body, which helps it release heat more efficiently in very hot conditions. One of the camel's best-known abilities is that it can go for long stretches without drinking water. This is not because it is ignoring thirst, but because its whole body is built to slow water loss and cope with dehydration in a controlled way. A camel can continue functioning in dry conditions that would quickly weaken many other large mammals, which is one reason it became such an important partner for people living and traveling in deserts. When water finally becomes available, camels can rehydrate with impressive speed. Their bodies are able to take in large amounts of water without the same level of shock that would affect many other animals. This rapid recovery matters in desert life because water sources can be rare and unpredictable, so a camel must make the most of the moment when it has a chance to drink. Camel red blood cells are unusual because they are oval or ellipsoid rather than round like the red blood cells of most mammals. That shape helps them keep moving through the bloodstream even when the camel is dehydrated and the blood becomes thicker. It is a small detail at the microscopic level, but it plays a major role in helping the whole animal survive harsh conditions. Those same red blood cells can also swell during rapid rehydration without bursting as easily as ordinary mammalian red blood cells would. That means the camel's body is protected during the sudden return of water after a dry period. It is a beautiful example of how camel biology is not based on one clever trick, but on many linked adaptations working together. Camels are able to let their body temperature fluctuate more than many other mammals. Instead of fighting to keep a narrow body temperature range at all times, they allow some daily rise and fall. This helps them save water, because they do not need to sweat as quickly or as heavily as other animals might in the same heat. In dehydrated camels, body temperature can shift roughly from 34 to 41 degrees Celsius. That is a very wide swing for a mammal, and it helps explain how camels handle desert heat so efficiently. During the hottest part of the day, the body can store heat rather than immediately spending precious water to cool down through sweating. Allowing body temperature to rise in the daytime reduces the need for cooling through evaporation. Sweating is effective, but it costs water, and in the desert, water is everything. Camels reduce that cost by tolerating heat within the body for a while, then releasing it later when the air becomes cooler. At night, some of the heat stored during the day can be released back into the environment. Desert nights are often much cooler than desert days, and camels make use of that contrast. Their survival is tied not only to resisting the daytime sun, but also to taking advantage of the rhythm between scorching daylight and cooler darkness. Camel nostrils can be squeezed shut against blowing sand. This is a simple but powerful adaptation for life in dusty, windy places. A sandstorm can make breathing and seeing difficult, but the camel's nose is part of a broader protective system that helps it remain functional in conditions that would overwhelm many animals. Camels have long eyelashes that shield the eyes from drifting sand. In some Bactrian camels, there are even 2 rows of long eyelashes, giving extra protection. These lashes are not just decorative or dramatic looking. They are part of the camel's survival equipment, helping it keep its vision in places where wind can fill the air with sharp dust. Camels also have a third eyelid, called a nictitating membrane, which adds another layer of eye protection. This thin membrane can help shield the eye while still allowing some vision. It is especially useful in dry, dusty environments where the eye needs constant defense against irritation and damage. Camel feet are broad and spread out underweight, which helps keep the animal from sinking deeply into loose sand. Instead of pressing into the ground like a narrow hoof, the foot acts more like a wide support pad. Their broad footing is one reason a heavy camel can move so steadily across ground that might seem impossible to cross. Camelids have 2 toes and very small hooves with a broad sole, giving them stable support on shifting terrain. This structure works not only on sand, but also on snow and rocky ground, especially for Bactrian camels in colder deserts. The camel is often imagined as an animal of dunes alone, but its foot design reveals a much wider range of terrain. A camel survives aridity through a whole collection of body systems, not by carrying a hidden water tank on its back. Its blood, kidneys, temperature control, nose, eyes, and feet all play a role in keeping it alive. The real wonder of the camel is not one famous feature, but the way many different features work together as a complete survival design. The popular myth that camels simply store water in the hump misses most of what makes them biologically remarkable. The true story is far more interesting. A camel is not a simple container built for dryness, but a deeply specialized mammal whose anatomy and physiology solve the problem of desert survival in many different ways at once. Wild camels are among the rarest large mammals in the world. This often surprises people because camels as a group seem so familiar and widespread. But the truly wild form is extremely scarce, which makes it both biologically important and a serious conservation concern. The wild camel is listed as critically endangered. That means it faces an extremely high risk of extinction in the wild. While millions of domesticated camels still exist, the original wild lineage survives only in very limited places, reminding us that a common-looking animal can still contain a vanishing wild history. The remaining wild camels survive only in a few desert areas of China and Mongolia. Their world is harsh, open, and remote, and their survival there shows just how resilient they are. At the same time, the small size of those remaining populations makes them vulnerable, which is why scientists and conservationists pay such close attention to them. This creates a striking contrast in the camel story. In one part of the world, wild camels are rare and protected, while in another, feral camels are abundant and even treated as invasive. It is unusual for one kind of animal to stand on both sides of that line at once. Camels are a reminder that biology, history, and human land use can produce very different outcomes in different places. Camels belong to the mammal family Camelidae, the same broader family that includes llamas, alpacas, vicunias, and guanacos. So the camel is part of a larger family story that stretches far beyond the deserts of Africa and Asia. When people think of camels, they often imagine only one familiar shape, but their relatives show that this family adapted to many kinds of landscapes. There are 3 living camel species: the dromedary, the domesticated Bactrian camel, and the wild camel. This gives us a simple starting point for understanding camel diversity. Even though these animals are related, they differ in body form, habitat, and history in ways that reveal how flexible the camel lineage has been over time. The dromedary is the one-humped camel most commonly associated with North Africa and the Middle East. It is the camel of many desert travel images, famous for endurance, riding, and hot climate adaptation. Its body form reflects a life centered on heat, distance, and dry landscapes. The Bactrian camel is the two-humped camel adapted to colder and more continental deserts of Asia. It is thicker, heavier, and more heavily coated than the dromedary. Where the dromedary is strongly linked with hot deserts, the Bactrian shows that camel life can also be shaped by freezing winters and wide seasonal extremes. The wild camel is not simply a stray domesticated animal living on its own. It is recognized as a distinct species, Camelus ferus, with its own evolutionary identity. That matters because protecting a wild species is not the same as managing domestic animals, even when they look related. Wild dromedaries are extinct, even though large feral dromedary populations now live in Australia. In other words, the original truly wild one-humped camel no longer survives in nature, but human history has created new free-living populations elsewhere. This difference between wild, domestic, and feral is important in understanding camel history accurately. Dromedaries make up the great majority of the world's camels. When most people picture a camel, they are probably thinking of the most numerous form. This dominance also helps explain why the one-humped camel has had such a large influence on transport, milk production, and desert life across broad regions. Africa is home to more than 80% of the world's one-humped camels. That makes the continent central to the modern camel story, especially in terms of food systems and pastoral livelihoods. Camels are not a minor side note in these regions. They are woven into daily life, survival, and local economies. Countries such as Ethiopia, Kenya, Somalia, and Sudan are among the key centers of dromedary production in Africa. These are places where camel herding is tied closely to climate, movement, and resource use. In many of these environments, the camel's ability to work with scarcity makes it especially valuable. Mongolia remains one of the world's major centers for domesticated two-humped camels. This is a reminder that camel importance is not limited to hot Arab deserts. In Mongolia, the Bactrian camel remains deeply connected to open rangelands, mobile herding, and the ecology of the Gobi. Camelids first evolved in North America before later spreading into South America and the Old World. That means the ancient roots of camel history lie far from the deserts most people associate with them today. It is one of the more surprising chapters in mammal evolution. The camel family began in one continent, then flourished elsewhere. Camels later disappeared from North America, even though their relatives survived in other parts of the world. So the place where camelids first evolved is not where modern camels remained. This gives their history a quiet sense of movement across deep time, shaped by migration, change, and extinction. The lineage leading to modern Old World camels split from the lineage leading to South American camelids millions of years ago. Over long stretches of evolutionary time, that family division produced very different kinds of animals adapted to very different environments. Yet they still share a common ancestral thread within Camelidae. The dromedary and Bactrian camel lineages split from one another roughly 4 to 5 million years ago. That means the one-humped and two-humped camels are close relatives, but their differences are not recent. Their separate paths gave rise to different bodies, different habitats, and different relationships with climate. Wild and domestic Bactrian camels separated from one another long before human domestication. This shows that the wild camel is not just a recent offshoot of domestic herding. Its history reaches back much deeper, and that is part of why it is treated as a distinct conservation priority. Domestication of Bactrian camels came much later than the evolutionary split between wild and domestic-related lineages. Humans did not create the camel from scratch. They entered an already ancient story and formed a practical partnership with an animal that had been adapting to hard environments for a very long time. Bactrian camel domestication is generally placed between about 6,000 and 4,000 years ago. That makes camel domestication part of a very old human strategy for living in dry, difficult landscapes. Once domesticated, camels became tools of movement, food, and survival on a scale few other animals could match. Archaeological and historical evidence links Bactrian camel domestication with Southwest and Central Asia, and dromedary domestication with Arabia. This means the two great domestic camel traditions emerged in different but related dryland worlds. Their later importance grew from these regional beginnings into much larger networks of trade and culture. Camels became especially valuable when people began using them for transport across dry lands. They were not merely animals that survived deserts. They were animals that allowed humans to move through deserts more reliably, carrying people, goods, and supplies across places where other transport animals struggled. Three major historical uses of domesticated camels were milk production, transport, and military service. This already shows how unusual the camel is among livestock. It was not only a source of food, but also a vehicle, a support animal, and a strategic asset in times of conflict. By the first millennium BCE, improved saddles made camels even more useful in trade and warfare. Better equipment made the animal's natural abilities even more valuable. In this way, human technology and camel biology worked together, allowing caravans and mounted travel to become more effective. Camel caravans transformed land transport across large, dry parts of Afro-Eurasia. They helped goods move across regions where roads were difficult, water was uncertain, and distance was a constant challenge. The camel was one of the great enablers of overland movement in arid zones. Camels became famous as the ships of the desert because they could carry people and cargo through terrain where many other animals would struggle badly. The phrase may sound poetic, but it reflects a real practical truth. In dryland history, camels served a role much like ships do at sea. They made difficult routes usable. Camels are herbivores, feeding on plant material rather than hunting other animals. This matters because it means they turn sparse vegetation into useful products like milk, fiber, and transport power. Even in poor landscapes, they are able to harvest nourishment from the plants available to them. A common group term for camels is a caravan. The word fits them especially well because it reflects not only the animals themselves, but the long tradition of camel travel in groups across desert routes. In a way, even the language around camels carries the memory of movement and trade. Dromedaries are generally built for speed and distance. Their form suits long travel under hot, dry conditions, and that is why they became famous as riding camels. Compared with heavier camel types, they are often more associated with swift, efficient movement across open desert. Bactrian camels are generally heavier and more thickset than dromedaries. Their bodies reflect a different ecological challenge, with colder climates and rougher seasonal extremes. They carry the same family strengths of endurance and adaptation, but in a bulkier form. Domesticated Bactrian camels can weigh up to about 1,000 kilograms, making them the heaviest camel species. This large body gives them an imposing presence and helps explain their strength as working animals. They are not only desert survivors, but also powerful carriers of loads in difficult terrain. Captive Bactrian camels can live up to about 50 years. That is a long lifespan for a working domestic mammal, and it helps explain the deep bond that can form between herders and their animals over time. A camel is not a short-term presence in human life. It can remain part of a household or livelihood for decades. Bactrian camels can stand over 7 feet tall at the hump. Their size alone helps explain why they seem so memorable when seen up close. Height, mass, thick fur, and twin humps combine to make them one of the most visually distinctive large mammals on Earth. Dromedaries have 1 hump, while Bactrian camels have 2. This is one of the easiest visible ways to tell them apart, but the difference is also a sign of deeper adaptation and evolutionary separation. The hump count is simple to notice, yet it points to long histories of divergence within the camel world. Camels do not store water in their humps because they already have other, much more effective ways to manage water throughout the body. Their survival depends on a full system of adaptation rather than one simple storage trick. This is important because it changes how we understand the animal. A camel is not surviving the desert through a single special feature, but through a carefully balanced set of body functions that all work together to reduce water loss, protect organs, and keep the animal moving even when the environment is extremely dry. One of the camel's most important water-saving strategies is the production of very concentrated urine. This means the body removes waste while losing as little liquid as possible. In many animals, water is used more freely when the body flushes out waste, but the camel is far more cautious. Its system pulls back and reuses as much moisture as it can, which allows the animal to hold on to precious body water for longer periods in hot and arid landscapes. Camels also produce very dry feces, which is another way they limit water loss. Moisture that might leave the body in waste is instead reabsorbed. This makes a big difference in dry climates because every small amount of saved water matters over time. The body of a camel is constantly acting like a careful manager, trying to spend as little water as possible while still keeping all essential systems working. When a camel is dehydrated, it may pass only a very small amount of urine. This shows how strongly the animal can shift into conservation mode. Instead of behaving like a body that expects easy access to water, the camel behaves like a body prepared for long uncertainty. This ability helps it stay alive and functional through long stretches when drinking simply is not possible. Camel kidneys are highly specialized for water recovery. Their job is not just to filter the blood, but to do so while keeping as much fluid inside the body as possible. In a desert animal, that is a major priority. The kidney structure helps return water to the body instead of letting it go, and this is one of the deeper hidden reasons camels can tolerate thirst so much better than most other large mammals. Scientists describe camel kidneys as having a long looped structure and a very well-developed inner region called the medulla, both of which help produce concentrated urine. This sounds technical, but the basic idea is simple. The kidney is built to pull water back out again and again before waste finally leaves the body. It is a strong example of how camel survival depends on internal anatomy, just as much as on visible desert features like humps or broad feet. Camels have heavy eyebrows that help shade and protect the eyes. In a desert, bright sunlight and airborne dust can both be constant problems. The eyebrows help reduce glare and also shield the upper part of the eye area. This may seem like a small feature, but in a place where vision can be easily disturbed by light and sand, even simple protective structures become very important. All of the camel's eye protection features help it stay active in dusty and windy environments. Long lashes, shaded eyes, and protective membranes all reduce the damage that blowing sand could cause. This matters because desert life often does not pause when the weather becomes unpleasant. A camel that can still see, move, and graze in difficult conditions has a major survival advantage. When a camel's foot presses down, it spreads under the animal's weight, and when the foot lifts again, it contracts. This flexible action helps the camel move efficiently on unstable ground. It is a quiet mechanical advantage. Instead of punching deeply into the sand, the foot adjusts itself to the surface, which supports the animal's heavy body while also reducing the energy needed to keep moving forward. Camel feet work not only on loose sand, but also on snow and rocky ground, which is especially important for Bactrian camels. This reminds us that camels are not only specialists of hot dunes. Some are adapted to cold, rough, and seasonally difficult terrain as well. Their feet are part of what allows them to handle these changing surfaces without losing stability. This broad and flexible foot structure gives camels steadier footing than a narrow hoof would provide on shifting ground. A narrow hoof can sink more easily or become unstable on loose surfaces. The camel's broader support spreads pressure over a wider area, which is a simple but powerful solution to moving through sand, gravel, and other uncertain terrain. Camels have long legs that lift much of the body above the hot ground. In deserts, the ground itself can become intensely hot under direct sunlight. By keeping the main body farther away from that heat, the camel reduces how much warmth rises into its core. The leg length is therefore not just about height or stride. It is part of the animal's strategy for heat management. Camels have thick calloused pads on the knees and chest, and these help protect the body when the animal kneels down. Since camels often rest, receive loads, or lower themselves to the ground in a kneeling posture, these pads act as built-in protection. Without them, repeated contact with rough or hot surfaces would be much more damaging. These callosities cushion the body when a camel lies down, making the motion safer and more comfortable. The camel is a large and heavy animal, and lowering that body to the ground again and again would create pressure on sensitive areas. These specialized pads solve that problem in a practical way, showing how camel anatomy supports not only movement, but also rest and working behavior. In dromedaries, the chest and knee pads are especially useful against very hot desert surfaces. The animal may kneel on ground that has absorbed heat for hours under the sun. These pads act as insulation and protection, reducing direct harm from the temperature of the earth below. Domestic Bactrian camels are usually darker, stockier, and woollier than wild camels. This reflects both domestication and adaptation to their environments. Their heavier build and richer coat make sense in colder and more variable climates, where insulation and mass can help the body handle harsh seasonal changes. Bactrian camels grow a much heavier coat than dromedaries. That coat is one of the clearest visual signs that the two main camel types are adapted to different conditions. Where the dromedary is built more for open heat, the Bactrian is prepared for cold winds, winter exposure, and strong seasonal contrasts. That thick Bactrian coat is one reason these camels can cope with very cold winters. It helps trap warmth near the body and protect the animal from freezing air. This is a useful reminder that camels are not only desert survivors in the sense of heat. Some are also highly capable of handling cold, provided the landscape is still dry and open enough to suit their broader way of life. Bactrian camels live in regions where winters can be bitterly cold and summers intensely hot. So they are not simply heat-adapted animals living in cold places. They are animals adapted to extreme contrast. Their bodies must handle freezing conditions in one season and punishing dryness and warmth in another, which makes them unusually flexible among large domesticated mammals. Dromedaries, by contrast, are much more closely associated with hot deserts and semi-deserts. Their bodies reflect a different balance of needs, favoring long-distance travel and heat management. Comparing dromedaries and Bactrians helps show that the camel family is not built around one single environment, but around different versions of scarcity and climate stress. Camels can survive on low-quality forage that many other livestock species avoid. This is one of the main reasons they are so valuable in harsh landscapes. In places where grass is sparse, coarse, salty, thorny, or dry, many animals lose condition quickly. Camels are better able to keep going on such resources, which turns difficult land into usable land. Camels can eat thorns, dry leaves, and saltbush. Plants like these are not ideal food for many animals, but camels are well equipped to handle them. Their feeding behavior is flexible, and their mouths are adapted to deal with plant material that is tough, spiny, or chemically challenging. This allows them to make use of vegetation that might otherwise go largely untouched. That feeding flexibility is one reason camels remain so important in harsh rangelands. In dry places, animals often cannot afford to be too selective. A camel's ability to use many kinds of forage means it can continue finding nourishment even when the plant world around it is sparse and uneven. Camels can maintain production in places where other domestic animals struggle to survive. This is especially important for milk and transport. A camel does not need a lush pasture to remain useful. It can keep supporting people in regions where cattle, for example, might fail much sooner under the same pressure. This is why camels are often described as climate-resilient livestock. They are not indestructible, but they are unusually capable of continuing to function under heat, dryness, and feed shortage. As changing climates place more stress on traditional farming systems, that resilience becomes even more important. Camels are especially valuable in hostile or marginal environments where conditions are not ideal for most livestock. The word marginal here simply means land that is difficult to use productively. Camels help turn that difficult land into a place where people can still obtain food, movement, fiber, and income. Camels are important not only for transport, but also for milk, meat, fiber, and manure. This makes them multi-purpose animals in the fullest sense. Instead of serving one role, they support many parts of life at once, which is especially useful in places where resources are limited and each animal must provide several forms of value. In many pastoral communities, camel milk is a daily staple rather than a rare or luxury food. It is part of regular nourishment and routine life. That means the camel's role is not only historic or symbolic. For many households, it remains a direct and ordinary source of nutrition. Camel milk can even become the main source of nutritious animal food for some people living in very dry environments. This shows how central the camel can be to food security. In areas where other forms of animal agriculture are difficult, camel milk becomes much more than a product. It becomes part of survival itself. In some pastoral communities, camel milk is especially important for children. It provides nourishment in regions where food options can be limited by climate and distance. When an animal can keep producing milk under harsh conditions, it becomes deeply tied to family health and everyday resilience. Camel milk is often still available during hot, dry seasons when other resources are scarce. This is one reason camels are so strongly linked to drought resistance. Even when conditions become difficult, the camel can continue to contribute food, and that gives it a powerful practical role in dryland livelihoods. Camel milk is notable for its vitamin C content, which is especially useful in places where fresh fruits and vegetables may not be consistently available. This gives the milk a special nutritional importance. In dry regions, a food source that brings both energy and important vitamins becomes especially valuable. Many reviews report that camel milk contains more vitamin C than cow's milk, sometimes several times more. This is one reason scientists and food experts often discuss camel milk separately, rather than treating it as just another version of dairy. Its nutritional profile has some distinct features that matter in real-world diets. Camel milk also contains iron and other essential nutrients. That broadens its value beyond hydration or basic calories. It is a meaningful food source, not just a survival substitute. This helps explain why camel milk is so highly regarded in many herding societies. Camel milk has drawn interest not only for its nutrition, but also because it contains bioactive compounds such as lactoferrin and alpha-lactalbumin. These are natural proteins found in the milk that attract scientific attention. Their presence helps explain why camel milk is studied not just as a traditional food, but also as a biologically interesting one. These compounds are part of why camel milk receives attention beyond ordinary dairy use. Researchers are curious about how the milk behaves, how it differs from cow's milk, and what its components might mean for nutrition and health. Even so, its main importance remains very practical. It feeds people in challenging places. Camel milk typically has lower sugar and cholesterol than cow's milk, according to recent reviews. This makes it stand out again as its own distinct dairy type. It should not be thought of as just an unusual version of familiar milk. In chemical makeup and food behavior, it has several differences worth noticing. Camel milk is also studied for possible metabolic and anti-inflammatory effects, although that is separate from its main role as food. In simple terms, scientists are curious about whether it might influence the body in special ways. But even without those extra questions, its core value as a dependable food in harsh environments is already very significant. Camel milk is not only sold in markets. In many regions, it is still mostly self-consumed by the people who herd camels. That means much of its value remains local and direct. It supports the household first before it ever becomes part of a wider commercial system. In some Gulf countries, more than 60% of camel milk is self-consumed. This shows that camel milk is still deeply connected to everyday domestic life, not only large-scale trade. It remains part of the intimate economy of the household and herd. In Somalia, a very large share of national milk production comes from camels. This is a remarkable reminder of how important camels can be to a whole country's food system. They are not always a side animal or specialty species. In some places, they are central. That level of production shows that camels can matter not only to small communities, but to national nutrition and economy. When a country depends heavily on camel milk, the camel becomes part of public food security, not just private herding tradition. Camel meat is also used, although milk is often the more culturally central product. This again shows the camel's multipurpose nature. Even when one product stands out most strongly, the animal still contributes in several different ways. Camel fiber is another important product, especially from Bactrian camels. The animal's coat can provide useful material for clothing, household goods, and trade. In dry land and cool desert settings, that fiber becomes another way the camel supports human life. Camel hair has long been used in winter clothing because it provides warmth and can be worked into useful textiles. This means the camel's value extends beyond food and transport into the world of material culture. The animal supports not only movement and nutrition, but also shelter and clothing. Long camel hair has been used to make felt for Mongolian yurts and tents. This is a very practical use in a cold, windy environment where strong, insulating materials matter. In this way, the camel helps create the very shelter that protects people from the same harsh climate it is adapted to endure. Camel hair has also been used in herdsmen's waterproof winter coats. That is another example of how closely human life and camel biology have been linked. The camel's body produces material that can then be turned into protection for the people who live beside it. Coarser camel hair can be used in bedding, rugs, felt, and structural textiles, while finer fiber from the undercoat may be used in softer and more valuable fabric. This means different parts of the coat serve different purposes. The camel's body is, in a sense, providing several grades of useful raw material at once. Camel dung has traditionally been used as fuel in dry regions where wood is limited. This may sound simple, but in treeless or sparsely wooded landscapes, fuel can be a serious need. Once again, the camel contributes not just in one obvious way, but in multiple practical ways that support everyday life. Camels are generally described as docile, though they can bite or kick when annoyed. Like many large domestic animals, they can be calm and useful while still requiring respect. Their size alone means that their behavior matters greatly to the people who handle them, and calm management has always been an important part of camel keeping. Camel milk can also be processed into powders, fermented drinks, and other dairy products, which shows that it is not limited to fresh consumption alone. This matters because fresh milk is not always easy to transport or preserve, especially in hot climates. Turning camel milk into longer-lasting forms can help extend its usefulness and allow it to reach more people. It also shows that modern food science is finding more ways to work with a milk that has been important in dryland life for a very long time. One challenge with camel milk is that it behaves differently from cow's milk during processing. That may sound like a small technical detail, but in dairy production it makes a big difference. Methods that work well for cow's milk do not always give the same result with camel milk. This is why camel dairy often needs its own specialized knowledge rather than simply copying techniques from more familiar milk industries. Making cheese from camel milk is especially tricky because it does not coagulate or set in exactly the same way that cow's milk does under standard cheese-making methods. In simple terms, it can be harder to get the milk to form the firm curds needed for many types of cheese. That is why producers and researchers have had to develop special approaches suited to camel milk's unique chemistry. Because of that difference, scientists and food producers have worked on specific technologies to improve camel milk cheese production. This shows that camel milk is not just a traditional food being left behind by modern systems. It is also becoming part of ongoing scientific and industrial problem-solving. The more people learn about its behavior, the easier it becomes to create new camel dairy products that are reliable and safe. Camel milk is important enough at the international level that work has been underway on standards for pasteurized camel milk. That means official bodies recognize it as a product that needs clear rules for quality and safety, just like other major foods. When a traditional animal product reaches the point of international standards, it shows that it has become part of a much wider food conversation. Camel milk is now consumed far beyond the regions where camels have traditionally been raised. In other words, it is no longer only a local or regional product. It has started entering broader markets and reaching consumers who may never have seen a camel in person. This shift tells us that camel milk is moving from being mostly a pastoral food into being part of global food interest. Camels often rest by folding their legs beneath the body and lowering themselves carefully onto the chest pad. This resting posture is one of their most familiar movements. It is also very practical because their bodies are built to do this without injury thanks to those thick protective pads. Watching a camel settle down may look slow and simple, but it reflects a body plan designed for repeated kneeling. This kneeling habit made camels especially useful as pack animals because loads could be placed on them while they were down. That made loading and unloading safer and easier for people. Instead of trying to fasten goods onto a tall standing animal, handlers could prepare the camel while it was close to the ground, then have it rise once everything was in place. Camels move with a pacing gait, meaning both legs on the same side move forward together. This is different from the walking pattern of many other mammals. It creates the rocking motion people notice when they ride a camel. That familiar swaying feel is not random at all. It comes directly from the way the animal's limbs coordinate during movement. That side-to-side pacing contributes to the rolling motion that riders often find so distinctive. For some people it feels smooth, and for others it can feel awkward at first. Either way, it is part of what gives camel travel its unique rhythm. The body of the rider is gently shifted with each step because of the camel's particular gait. Camels were prized not only because they could move quickly, but because they could keep moving over long distances in dry conditions. Endurance was often more valuable than raw speed. In harsh landscapes, the ability to travel far without constant water and feed mattered much more than a short burst of fast movement. The dromedary in particular became famous as a riding camel. Its body was well suited to long-distance travel, and its speed and stamina made it especially useful for moving people across deserts. In many historical settings, that made it far more than just a work animal. It became an essential partner in travel and communication. The word dromedary comes from a root associated with running or swift movement. So even the name of the animal reflects how people understood it. Language often preserves what mattered most, and in this case, it preserves the idea of a camel built for motion. Camels can browse shrubs as well as graze more ground-level vegetation, which broadens the range of plants they can use. This gives them flexibility in landscapes where food may be scattered in different forms. They are not limited to one feeding style. They can reach into bushes and make use of tougher or less obvious plant resources. That feeding strategy allows camels to use sparse desert vegetation that is patchy in both quality and quantity. In a harsh environment, food is often not evenly spread out. A camel's ability to take advantage of many kinds of plants helps it continue finding nourishment where a more selective animal might struggle. Camels can tolerate protein deficiency better than many livestock species. In simple terms, they can cope better when the food available is not especially rich or balanced. That does not mean poor nutrition has no effect on them, but it does mean they are better equipped than many other animals to continue functioning under limited forage conditions. Salt bush and thorny shrubs that challenge other grazers can still become part of a camel's diet. This gives camels access to food that is often ignored or avoided by other animals. It is one more reason they fit so well into dry regions, where the plants available may be tough, salty, spiny, or scattered. This diet flexibility helps camels remain productive during drought. While other livestock may lose condition quickly as forage quality drops, camels are often able to keep making use of what remains. That resilience has major importance for people whose livelihoods depend on animals continuing to provide milk, labor, or breeding value during hard seasons. Camels are particularly associated with nomadic and semi-nomadic pastoral systems. These are ways of life built around movement, seasonal grazing, and flexible use of land. Camels fit well into these systems because they themselves are adapted to mobility and uncertainty. In such systems, mobility is essential because rainfall and forage are unreliable. People and animals may need to move in response to changing conditions rather than staying in one place. Camels make this possible by traveling well over long distances and by coping with sparse resources along the way. Camels support mobile livelihoods in areas where settled crop agriculture is difficult or impossible. In these places, animals become a more reliable way to turn the landscape into food and value. The camel is especially important because it can help people live productively in land that might otherwise seem too harsh for sustained human use. That makes camels economically important even where their total numbers are lower than cattle or sheep. A species does not need to be the most numerous to be essential. In many dry lands, camels may play a bigger practical role than their numbers alone would suggest because they do things other livestock cannot do as well. International organizations have emphasized that camelids contribute to food security, nutrition, and economic growth. This means camels are now being discussed not only as traditional animals, but also as part of larger development planning. Their value is being recognized on a wider scale because they help support both households and regional economies. The United Nations declared 2024 the International Year of Camelids. This was meant to draw attention to camelids around the world and to the people who depend on them. A declaration like that may sound symbolic, but it also helps encourage research, awareness, and policy interest. That International Year was intended to highlight the role of camelids in the livelihoods of millions of households. This includes not only those who raise camels, but also those who depend on related animals such as llamas and alpacas. It reminds us that camelids are not rare curiosities. They are part of daily life for many communities. Camelids matter in more than 90 countries. That is a surprisingly large global footprint for a family often imagined as limited to a few deserts or mountain regions. Their importance stretches across very different environments and cultures, showing how broad the camelid story really is. The International Year of Camelids did not focus only on Old World camels. It also included alpacas, llamas, vicunias, and guanacos. This broader view helps us understand camels not as isolated oddities, but as part of a wider family of mammals that humans have relied on in different ways. Camels are therefore part of a much larger story about how people live in difficult environments, from deserts to highlands. Their relatives in other regions support fiber, transport, and livelihoods in ways that echo the camel's own role. The family as a whole is deeply connected to human adaptation under challenging conditions. In many societies, camels are cultural symbols as well as working animals. They can represent endurance, wealth, heritage, and identity. This cultural meaning matters because it shows that the camel is not only useful in a practical sense, it also carries emotional and social significance. Camels are often described as part of the culture and identity of the communities that raise them. For many herders, they are tied to memory, tradition, and belonging. The knowledge of how to manage them, move with them, and benefit from them can be passed down across generations. Camel keeping is often linked to specialized knowledge of pasture, water points, and seasonal movement. Raising camels well requires more than simply owning them. It requires an understanding of the landscape, the weather, and the behavior of the herd. In that sense, camel keeping is a skill system as much as an economic activity. The social importance of camels can be just as strong as their nutritional importance. They may affect status, marriage arrangements, wealth, and local reputation in some societies. So even when people speak about camels as milk or transport animals, their role can reach much further into community life. In several regions, camels function as status animals in addition to being practical livestock. Owning many camels, or especially valued camels, can carry social meaning. This shows once again that the camel is not just a tool. It can also become a marker of prestige and identity. Modern camel industries now include tourism and sport in addition to traditional pastoral uses. This means the camel's place in society has expanded rather than disappeared. While some old uses remain, new ones have emerged that connect camels to entertainment, heritage display, and modern business. Camel racing remains a major sport in parts of the Arabian Peninsula and nearby regions. These races involve careful breeding, training, and management. They show that camels are not only animals of slow caravans in the popular imagination. They can also be part of highly competitive and specialized modern sport. Camel racing changed significantly when remote-controlled robot jockeys were introduced. This was an important development because it altered both the practice and the ethics of the sport. Technology reshaped a traditional activity, showing that camel use continues to evolve with time. These robot jockeys can be controlled from a distance while the camel runs. In simple terms, the rider is replaced by a lightweight device operated remotely. This shows how an ancient animal can become part of a very modern sporting system that combines tradition with engineering. Camel breeding for sport has become highly specialized in some countries. Animals may be selected very carefully for speed, endurance, or certain physical traits. This kind of breeding turns the camel into part of the focused performance culture, much like specialized breeding in other racing animals. Camel cloning has also been reported in places such as Dubai for animals valued for speed or beauty. This may sound futuristic, but it reflects the high value placed on exceptional individuals. When an animal is considered outstanding, biotechnology may be used in an attempt to preserve or repeat its qualities. That cloning work uses somatic cell nuclear transfer, a process in which DNA from a body cell is placed into an egg cell whose original DNA has been removed. The science is complex, but the basic idea is to reproduce the genetic makeup of a specific animal. It is striking to see such advanced biotechnology applied to a species so strongly associated with ancient pastoral life. The existence of camel cloning shows how an old livestock species can become connected to very modern science. Camels are not simply relics of the past. They continue to move into new spaces, including laboratories, breeding programs, and advanced reproductive technologies. Camel beauty competitions also exist and can influence breeding priorities. In these settings, appearance itself becomes important. Traits considered attractive or impressive may affect which animals are valued most highly, showing again that camel culture today includes more than survival and transport. Some racing camels are later redirected into beauty competition circuits. This means a camel's career can shift from one kind of prestige role to another. It also shows how multiple industries can grow around the same animal, depending on what traits are prized. This means camels today may be selected not only for endurance or milk yield, but also for aesthetic traits. Breeding decisions can be shaped by what people find visually desirable. In this way, human taste adds another layer to the camel's already complex relationship with people. Camels also contribute to tourism through rides, festivals, and heritage events. For many visitors, the camel becomes a living symbol of a landscape and its history. Tourism can turn the camel into an ambassador of cultural memory as well as a practical animal. In some dryland economies, camel work now overlaps with recreation, heritage, and media industries. This overlap is important because it shows that the camel is not locked into one old role. It can remain relevant by fitting into newer forms of value and public attention. Despite all these modern uses, the camel's basic importance still rests on its adaptation to harsh environments. Racing, tourism, and biotechnology may be new layers, but the foundation remains the same. The camel matters because it is extraordinarily good at living where life is difficult. One reason camel populations are attracting more attention is that they may become even more important under climate variability. As conditions become hotter or drier in some regions, animals that tolerate stress well may become more valuable. Camels are therefore increasingly seen not just as traditional livestock, but as part of future resilience. Camel populations are increasing in some challenging environments because they perform well where other livestock do poorly. This does not mean camels are replacing all other animals everywhere, but it does show that people respond to ecological pressure by turning towards species that cope better with heat, drought, and poor forage. Camels can graze poor quality resources and still remain productive. This simple fact is one of the deepest reasons for their long success. They are able to turn difficult landscapes into useful output, which is exactly what makes an animal valuable in places where resources are limited. They can also handle extreme heat better than most conventional dairy animals. This gives them a special place in dryland food systems. A milk-producing animal that can keep working in hot conditions becomes especially important where water and pasture are both under pressure. Camel racing remains a major sport in parts of the Arabian Peninsula and nearby regions. This may surprise people who think of camels only as slow caravan animals because racing reveals a very different side of them. In these events, camels are bred, trained, and managed with serious attention, much like other elite racing animals. The sport reflects how deeply camels remain woven into modern life in some regions, not just as symbols of the past, but as living participants in competition and public culture. Camel racing changed in an important way when remote-controlled robot jockeys were introduced. This was more than a small technical update. It changed how the sport was organized and helped move it away from older practices that raised major ethical concerns. The shift shows how a traditional activity can keep going while still adapting to new standards and technology. Robot jockeys were introduced in races in places such as Egypt as an alternative to child riders. That change was significant because it addressed welfare concerns while allowing the sport itself to continue. In this way, camel racing became an example of how technology can reshape a long-standing cultural practice without removing the camel from the center of it. These robot jockeys can be controlled from a distance while the camel runs. In simple terms, the rider is replaced by a lightweight device mounted on the camel's back, and the human controller follows remotely. It is a striking image because it combines one of the world's oldest domestic animals with a very modern kind of machine-guided sport. Camel breeding for sport has become highly specialized in some countries. This means breeders may focus intensely on speed, endurance, body shape, and other performance traits. Over time, that kind of selective breeding creates animals that are valued not just for general usefulness, but for excellence in one very specific role. Camel cloning has also been used in places such as Dubai for animals prized for speed or beauty. This shows just how valuable some camels can become. When a particular animal is considered exceptional, people may use advanced biotechnology in hopes of preserving its genetic qualities. It is a modern development that would have seemed almost unimaginable in the older caravan age. That cloning work uses a method called somatic cell nuclear transfer. The scientific language sounds complex, but the basic idea is that genetic material from one animal is used to help create another with the same DNA. This is one of the clearest examples of how camel breeding has moved into the world of high-level laboratory science. In this process, DNA from a body cell is placed into an egg cell whose original DNA has been removed. The result is an embryo carrying the genetic information of the original donor animal. What makes this especially fascinating in the camel world is the contrast between the old image of desert herding and the very advanced lab techniques now being used. The existence of camel cloning shows how an ancient livestock species is now tied to advanced biotechnology. Camels are often presented as symbols of tradition, and that is true, but they are also part of very modern industries. Their story now includes genetics labs, reproductive technology, and specialized breeding strategies alongside milk production and desert travel. Camel beauty competitions also exist and can influence breeding priorities. In those settings, people judge camels partly on appearance, and certain physical traits may become especially desirable. This means that aesthetic value, not only practical value, can shape which camels are considered most important or prestigious. Some racing camels are later redirected into beauty competition circuits. This shows that one camel can move between different kinds of value systems during its life. An animal first admired for athletic performance may later be appreciated for appearance, pedigree, or cultural prestige, which adds another layer to the modern camel economy. This means camels today can be selected for aesthetic traits as well as endurance or milk yield. In other words, people may breed camels not only for what they do, but also for how they look. That tells us a great deal about the wide range of roles camels now play, from everyday subsistence to elite display. Camels also contribute to tourism through rides, festivals, and heritage events. For visitors, the camel often becomes a living symbol of the desert and of older forms of travel. Tourism turns the animal into part of a shared cultural experience, where practical use, storytelling, and visual identity all come together. In some dryland economies, camel work now overlaps with recreation, heritage, and media industries. This means camels are not only useful in the field or household, they also appear in public celebrations, performances, filmed events, and visitor experiences. The camel's role continues to expand rather than shrink. Despite these modern uses, the camel's basic importance still rests on its adaptation to harsh environments. Sport and tourism may add value, but the foundation remains the same. The camel matters because it can live, move, and produce under conditions that would be much harder for many other domestic animals. One reason camel populations are attracting more attention is that they may become even more important under climate variability. As some regions face hotter temperatures, more erratic rainfall, and greater pressure on grazing systems, camels begin to look even more valuable. Their older strengths may become newly important in the future. Camel populations are increasing in some challenging environments because they perform well where other livestock do poorly. This does not mean they replace all other animals everywhere, but it does show that herders often respond practically to changing conditions. When one species handles drought and heat better, people naturally become more interested in it. Camels can graze poor quality resources and still remain productive. That simple ability is one of the strongest reasons they continue to matter. They can use landscapes that might seem too dry, too sparse, or too rough for other forms of animal production and still provide milk, labor, or breeding value. Camels can handle extreme heat better than most conventional dairy animals. This gives them a special advantage in areas where rising temperatures are making livestock management more difficult. A milk-producing animal that keeps functioning under strong heat pressure is extremely valuable in dryland food systems. In arid zones, camels are often described as better food providers than cows under severe heat and water shortage. This does not mean cows have no value, but it does highlight a major difference in how these animals respond to harsh conditions. Camels are simply better built for scarcity. Camels can also tolerate harsh cold, which is especially important for Bactrian herds. This reminds us that the camel story is not only about blazing heat. Some camel populations live in regions with freezing winters, strong winds, and snow, yet they still remain useful and resilient there. That combination of heat tolerance and, in some species, cold tolerance is unusually broad for livestock. Very few domestic animals are so strongly connected to both ends of environmental stress. This helps explain why camels have such a special place in the study of animal adaptation. Wild camels are among the rarest large mammals in the world. This is a striking fact because camels seem so familiar in human life. Yet the truly wild fawn survives in very small numbers, making it one of the more fragile large animal lineages on Earth. The wild camel is listed as critically endangered. That category means the species faces an extremely high risk of extinction in the wild. It is a reminder that being related to common domestic animals does not protect a wild species from disappearing. The remaining wild camels survive only in a few desert areas of China and Mongolia. Their range is narrow, and the environments they live in are demanding. These few remaining populations carry the last thread of a much older wild history. Some descriptions place the wild camel population at fewer than 500 individuals. Even allowing for changes in estimates over time, that is a very small number for a large mammal. It means every surviving group matters greatly for the future of the species. Other simplified sources have given even lower figures, such as fewer than 400 animals in surviving wild herds. Different estimates can vary depending on date, method, and how the animals are counted. But whichever figure one uses, the central truth remains the same. The wild camel is extraordinarily rare. What does not vary across sources is that the wild camel is extremely scarce. The exact number may shift as surveys improve, but the conservation message stays consistent. This is not an abundant animal living quietly out of sight. It is a species at the edge of survival. Conservation concern is one reason the wild camel receives so much scientific attention. researchers are not studying it only out of curiosity. They are also trying to understand, monitor, and protect one of the world's most threatened large desert mammals. Domestic Bactrian camels and wild camels differ not only genetically but also in body build and skull shape. These differences matter because they show that the wild camel is not simply a domestic animal living without people. It has its own biological identity. Wild camels are generally smaller and lighter than domestic Bactrians. Their difference may reflect both evolutionary history and the contrasting pressures of life in the wild versus life under domestication. Domestic animals are often shaped by human preferences, while wild ones remain shaped primarily by natural survival. Domestic Bactrians usually have a more rounded skull than wild camels. Details like skull shape may sound technical, but they help scientists distinguish lineages and understand how different forms of camel have developed over time. Morphology, in this case, helps tell a deep evolutionary story. Wild camel conservation is separate from the management of domestic or feral camel populations elsewhere. This is important because people sometimes assume all camels fall into one broad category. In reality, conserving a rare wild species is very different from handling domestic herds or managing overabundant feral populations. Australia is famous for having a huge feral camel population. This is one of the most unusual chapters in camel history. In a continent far from the camel's original Old World centers, large numbers of free-living camels now roam because of human introductions in the past. Those Australian camels descend from animals imported in the 19th century. They were not part of the original wildlife there. They arrived because people brought them in for practical work, and only later did they become the foundation of a major feral population. Imported camels were used in Australia for transportation and labor in arid interior regions. At that time, they were extremely useful in landscapes where distance, dryness, and difficult ground made travel hard. In that sense, their introduction followed the same logic that made them important in other dry parts of the world. Once motor transport became dominant, many camels were released or escaped, helping create feral populations. This is a common pattern in animal history. A species brought for work remains after the original need has changed. In Australia, that pattern eventually produced one of the largest feral camel populations anywhere. Australia's feral camels show how well dromedaries can thrive when desert conditions suit them. Once free living in a favorable environment, they proved fully capable of surviving and reproducing on their own. Their success there is another sign of just how effective camel desert adaptations really are. But that success can also create environmental and management problems. An animal that thrives too well outside its original management system can place pressure on ecosystems, infrastructure, and water sources. So the camel in Australia is not only a success story, it is also a management challenge. In some regions, feral camels in Australia have been described as a destructive invasive species. This means they may damage vegetation, compete for limited resources, and create problems for land use or conservation. The same desert toughness that makes camels valuable can also make them difficult to control once they spread freely. The impacts of feral camels in Australia are often grouped into environmental, economic, and social or cultural categories. In other words, their effects are not limited to plants or land alone. They can also influence infrastructure, local livelihoods, and places with cultural importance to communities. This creates an unusual contrast. Camels are protected and rare in one place, but overabundant and treated as pests in another. Few animals illustrate this contrast so clearly. It shows how the same biological strengths can lead to very different outcomes depending on location and history. Camels have long been connected with trade routes linking deserts to cities and ports. Their endurance helped move goods through dry zones that might otherwise have formed barriers. In this sense, camels were not just transport animals. They were connectors between worlds. Archaeological evidence of camel remains from southeastern Arabia helps document their early history. Bones and other remains provide physical clues that written records alone cannot fully supply. This evidence helps researchers understand when and where camels became part of human life. Evidence from places such as Tel Jemeh has been used to study early camel caravans and pastoralism. Archaeological sites like these matter because they provide concrete traces of camel use in earlier societies. Through them, historians can piece together how camel-based movement and herding developed over time. The archaeological record is patchier than the modern ubiquity of camels might suggest. Because camels became so famous later, people sometimes imagine their earlier history must be equally obvious in the evidence. But the record is uneven, and that makes the story more complex. Written and artistic evidence for early domestic camels in the Near East is not evenly distributed through time. Some periods offer clearer signs than others. This unevenness helps explain why camel domestication remains an active historical topic rather than a fully settled one. That uneven evidence is part of why camel domestication continues to be discussed and debated by scholars. When the material record is incomplete, interpretation becomes more difficult. Each new piece of evidence can shift how researchers understand the timeline and spread of camel use. One historical strength of camels was their ability to carry goods across places where wheeled transport was impractical. Wheels work best on prepared surfaces, but deserts and rough drylands often do not offer that. Camels made movement possible where roads and carts were not reliable solutions. Their value increased in places with few reliable water sources. The more difficult it was to find water, the more useful a water-efficient transport animal became. This turned the camel into a major advantage in trade, travel, and survival across dry landscapes. Camels helped connect oasis settlements with wider trade networks. An oasis in a desert is more than just a patch of water and plants. It is often a resting point, a place of exchange, and sometimes a small center of settlement in an otherwise difficult landscape. Camels made these places much more useful because they allowed people and goods to move between them across long, dry distances. In that way, camels helped turn isolated water points into linked systems of trade and communication. Their use in warfare came from mobility and endurance more than from raw pulling power. A camel was valuable in military settings because it could move men and supplies through harsh terrain where speed and reliability mattered. In deserts, it was often not enough to simply have strength. An animal had to keep going with limited water, little feed, and difficult ground, and camels were unusually suited to that role. Camels could also transport military supplies across difficult terrain. Armies depend not only on fighters but on food, water, equipment, and communication. In drylands, camels helped carry those essentials through places where wagons and many other pack animals would struggle. This made them important logistical animals, not only riding animals. In some historical settings, camel ownership was directly linked to wealth and social rank. That makes sense when we remember how much value a camel could provide. It could carry goods, produce milk, support travel, and survive in harsh land. Owning camels meant owning movement, food, and resilience, so it is natural that they also became signs of status. Camels are strongly associated with Bedouin and other desert pastoral traditions. In these traditions, camels are not simply useful livestock. They are part of the entire pattern of life, including movement, food, shelter, identity, and memory. Their presence shaped how people traveled, what they ate, and how they understood the land around them. Some descriptions of desert peoples emphasize how heavily they depended on camels for milk, transport, and materials. This dependence was not a small matter. It meant the camel helped support both daily survival and long-distance life in environments that would otherwise be much harder to inhabit. The animal became part of the human strategy for living with scarcity. Camel leather and camel hair have also supported crafts as well as subsistence. That means the camel's usefulness extended into the making of goods, clothing, containers, and other practical items. The relationship between people and camels was not only about riding or milking. It also included transforming parts of the animal into materials for daily life. The usefulness of camels therefore extends far beyond riding. When people imagine camels only as animals carrying riders across sand, they miss most of the picture. Camels have fed people, clothed them, sheltered them, fueled their fires, moved their goods, and supported their economies. Their role has always been much wider than the simplest stereotype suggests. Female camels generally leave the herd to find a more private and sheltered place before giving birth. This behavior helps reduce disturbance during a very vulnerable moment. In open landscapes, finding a quieter place can improve the safety of both mother and calf. It also shows that even large herd animals may seek seclusion when reproduction begins. Camel gestation lasts about 12 to 14 months, which is a relatively long pregnancy compared with many common farm animals. This means that each calf represents a major investment of time and energy from the mother. Long gestation often goes together with slower reproduction, and that helps explain why camel populations do not grow as rapidly as some other domestic animals. Because camel calves are carried for such a long time before birth, each new calf is especially important. The mother spends many months supporting its growth, and after birth, there is still a great deal of care required. This long process is one reason camel reproduction is often considered low output compared with more rapidly reproducing livestock. Newborn camel calves are born without fully formed humps. This surprises many people because the hump seems like such a defining camel feature. But like many body structures, it develops over time. At birth, the cathay has only the beginnings of what will later become the mature hump or humps. Instead of full humps, newborns have small raised areas of skin showing where the humps will later develop. These early forms may not look dramatic, but they mark the locations of one of the camel's most famous adult features. It is a quiet reminder that even iconic body structures begin in a much smaller and softer state. Those early hump markers can be topped with curly hair, giving newborn camel calves a slightly unusual appearance. The young animal does not yet look exactly like the familiar adult silhouette. Development changes that over time, as the body grows and the hump structure becomes more defined. Camel calves become mobile very quickly after birth. This is extremely useful in open environments where staying still for too long could be risky. A newborn that can get up and move soon after arrival has a better chance of staying with its mother and the herd. A newborn camel calf may be able to walk beside its mother within about half an hour. That is an impressive beginning for such a large young animal. Rapid early movement helps the calf remain connected to maternal care and reduces the danger of being left behind in exposed terrain. Some descriptions note that baby Bactrian camels can even run when they are only a few hours old. This quick progress is important in a species adapted to open and sometimes harsh landscapes. The faster a calf can coordinate its body, the more easily it can keep pace with the group. This rapid mobility is useful because lingering too long at the birth site would increase risk. In wild or open conditions, the safest strategy is often to move on once birth is complete. A calf that can follow early gives the mother greater flexibility and improves the pair's chance of staying secure. Camel reproduction is usually low output, with mothers commonly producing a single calf rather than many young at once. This means each birth matters a great deal. It also means that population recovery can be slow, especially in wild camels, because losses are not quickly replaced. That slow reproductive pace makes losses especially serious for rare wild populations. When a species produces young only gradually, every death matters more. In conservation terms, slow breeding can make recovery difficult even if protection improves, because the population cannot rebound quickly. Camel calves depend heavily on their mother's milk during early life. The milk is not only food, but the main bridge between the calf and survival. In difficult environments, dependable maternal milk can make the difference between a strong start and a dangerous one. That strong maternal investment helps explain why camel milk is so important both biologically and culturally. It matters first for the cafe, but it also becomes part of human life because people have long depended on that same milk for nourishment. So the biological importance of milk and the cultural importance of milk are closely linked. Camels communicate through posture, movement, and vocalization, even if people do not always notice how expressive they can be. Their communication may not seem as obvious as that of some other domestic animals, but it still plays an important role in social interaction, handling, and herd life. Their large lips and mobile muzzle help them browse and manipulate tough vegetation. This gives them fine control when selecting plant material from shrubs, thorny growth, or scattered forage. The mouth is not only strong, but also skillful, which is useful in environments where edible plants may be difficult to handle. A camel split up a lip helps it feed selectively among thorny plants. This structure allows the animal to grasp and sort vegetation more carefully. In places where food is rough, spiny, or irregular, the ability to handle specific plant parts without excessive injury is a major advantage. Thickened tissues in the mouth help camels tolerate prickly and abrasive forage. Many other animals would avoid or be harmed by such plants more easily. Camels, however, can continue feeding on material that might tear softer mouths, which expands the range of food they can safely use. Because of these mouth adaptations, camels can continue eating plants that would injure more delicate grazers. This makes them especially suited to dry landscapes where the vegetation often protects itself with thorns, toughness, or harsh textures. Their feeding equipment matches the challenges of the plants around them. Camel browsing behavior can influence vegetation differently from the grazing behavior of animals like sheep or cattle. Since camels often feed on shrubs and browse higher vegetation as well, they interact with plant communities in their own distinct way. This means they do not shape rangelands exactly like other livestock. Camels are ruminant-like foregut fermenters, but they are not true bovids like cattle, sheep, or goats. In simple terms, they process fibrous plant food using a specialized foregut fermentation system, yet they belong to a different evolutionary line. That makes them similar in some digestive ways to classic ruminants, while still remaining biologically distinct. This combination of camelid anatomy and herbivorous digestion sets them apart from more familiar livestock. Their bodies solve some of the same feeding problems as cattle or sheep, but through their own camelid form and history. That difference is part of what makes camels so interesting in comparative biology. Camel stomach anatomy supports the breakdown of fibrous, poor-quality plant material. This means camels can extract value from food that looks dry, coarse, or nutritionally limited. Their digestive system is not careless. It is highly adapted to making the most of difficult forage. That digestive resilience is another reason camels remain valuable in degraded rangelands. Even when plant quality falls and landscapes become more stressful for other animals, camels can continue turning that vegetation into useful output. Their digestion is one of the foundations of their practical worth. The heavy winter coat of Bactrian camels is often shed seasonally. This tells us that their fur is not static, but part of a cycle, that helps match the body to changing conditions. A thick coat is useful in winter, but once warmer conditions return, keeping all of it would become less practical. This seasonal shedding is important for fiber collection in some regions. People can gather valuable camel fiber during this natural process, turning a biological cycle into an economic opportunity. In that way, the camel's coat supports both the animal's comfort and human use. Camel hair is often collected by combing or gathering shed fiber rather than only by shearing. This can be a practical method when animals naturally release large amounts of undercoat. It also allows people to make use of fiber that the camel is already ready to lose. The finest camel fiber generally comes from the soft undercoat rather than the coarse outer hair. That undercoat is warmer, softer, and more suitable for high-quality textiles. This difference between coat layers helps explain why camel fiber can range from very rough utility material to fine clothing fabric. Coarser camel hair is still useful for felt, rugs, and structural textiles. So even the less delicate parts of the coat have value. In traditional settings especially, different grades of fiber can be matched to different household needs, with little going to waste. Fine camel fiber is associated with soft, warm, luxury textiles. This shows that the camel's usefulness extends into both ordinary daily materials and more refined products. One animal can contribute to practical survival and to premium craftsmanship at the same time. Camel populations are sometimes overlooked in global livestock discussions because they are concentrated in harsher regions that often receive less attention and weaker data coverage. Yet this does not mean they are unimportant. It often means they are important in places the wider world has not always studied carefully enough. Despite that relative invisibility, camels are repeatedly highlighted as strategically important for resilient food systems. Their value becomes especially clear when heat, drought, and poor forage are considered. They may not dominate in global livestock numbers, but in certain environments they are among the most sensible animals to depend on. Camels can provide traction and draft power, as well as riding and packing services. This means they are useful not only for carrying loads on their backs, but also for pulling and supporting work in other ways. Their physical strength broadens their role in transport and labor. Because of that, camels can help move agricultural goods and equipment, in addition to people. In rural dryland settings, this can be extremely important. An animal that transports supplies, products, or tools over difficult ground becomes part of the wider working system of life and trade. In some countries, camels support jobs in milk collection, milk processing, transport, sport, and tourism. Their importance therefore reaches beyond the herding household itself. A camel economy can include many layers of work, from direct animal care to business and service roles farther down the chain. Camels are therefore part of both subsistence economies and commercial value chains. They help families survive directly, but they can also contribute to larger markets and industries. This dual role helps explain why camels remain relevant in both traditional and changing economic systems. Some of the camel's most valuable traits are hidden inside the body, such as its efficient control of water and electrolytes. These are not the kinds of things a casual observer sees from the outside, but they are some of the deepest reasons the animal succeeds. Internal regulation is part of what makes the camel so extraordinary. Camel physiology has become an important model for studying adaptation to heat and dehydration. Scientists are interested in camels, not only because they are useful animals, but because they help reveal how mammals can survive severe environmental stress. In that sense, camels teach biology as well as support livelihoods. Their blood, kidneys, temperature control, and eye protection all contribute to desert survival. No single adaptation explains everything on its own. It is the combination that matters. The camel survives because many different systems protect it at the same time. No single camel trait fully explains its endurance. It is not just the hump, or the blood, or the kidneys, or the feet. What makes the camel remarkable is the way all these adaptations connect into one coordinated body strategy for coping with scarcity and stress. Camels have been part of human adaptation to deserts for thousands of years. People did not simply admire them from a distance. They built ways of life around them. In dry regions, the camel became one of the great living tools that made long-term human presence possible. Camels changed how people could move, trade, and live in dry continental interiors. Before animals like camels were used widely, crossing large desert regions was far more difficult and risky. The camel made long-distance travel more reliable, allowing people to carry supplies, connect distant communities, and build trade routes that stretched across vast, dry landscapes. They also changed diets by making regular milk production possible in places with little water. In many dry environments, growing crops or keeping water-dependent animals can be very difficult. Camels helped solve part of that problem by providing a steady source of milk, even when conditions were harsh. This gave people access to nutrition in areas where food options were otherwise limited. In that sense, camels are both transportation technology and food production systems at the same time. They are not just animals that carry goods or produce milk separately. They combine both roles into one living system, supporting movement and nourishment together in environments where resources are scarce. Ancient camel use was shaped strongly by geography, especially the availability of water and the difficulty of terrain. Where deserts, dry plains, and long distances dominated, camels became essential. Their importance grew directly from the environment, showing how animal use often follows the demands of the land. Modern camel use, however, is shaped not only by geography, but also by science, regulation, and markets. Today, camels are part of food standards, global trade, and even biotechnology. This means the camel's story is no longer only about survival in deserts. It is also about how traditional animals fit into modern systems. Camel milk standards, cloning, and racing technology all show that the camel is not just an animal of the past. It continues to adapt to new roles in a changing world. What began as a survival partner in drylands has become part of industries, research, and global interest. Even today, camels continue to be integrated into new industries. As people look for resilient livestock and unique products, camels offer possibilities that other animals may not provide. This keeps them relevant, even as technology and lifestyles evolve. At the same time, traditional herding knowledge remains essential for keeping camels healthy in open rangelands. No amount of modern technology can fully replace the understanding that herders have developed over generations. Knowing where to move, when to graze, and how to manage animals in changing conditions is still critical. Mongolia's camel sector is strongly tied to open rangeland nomadism. This means camels are part of the lifestyle built around movement and seasonal patterns. They are not kept in confined systems, but instead move across wide landscapes that change with the seasons. Mongolian camel milk has been recognized as a valuable product with both nutritional and economic importance. It supports local communities and also has the potential to reach wider markets. This highlights how, even in remote regions, camel products can connect to broader systems. Mongolia's camels mainly graze in the Gobi, a vast region known for its dry conditions and extreme temperatures. Living in such a place requires animals that can handle both heat and cold, as well as limited vegetation. Camels are one of the few large domesticated animals that can thrive there. Mongolia has hundreds of thousands of camels, mostly domesticated Bactrians. This large population shows how important camels remain in certain parts of the world. They are not rare everywhere, In some regions, they are still a major part of everyday life and economy. This makes Mongolia one of the strongest examples of large-scale two-humped camel herding today. It shows that Bactrian camels are not only relics of the past, they continue to play an active role in modern livelihoods. Bactrian camels often gather around mountains, snow, and springs in the Gobi during winter. Even desert animals must seek out specific resources when conditions change. This behavior shows how camels adjust their movement based on the environment, not just on instinct, but also on availability of water and shelter. This behavior reveals that even highly adapted animals depend on key landscape features. Survival is not only about toughness, it is also about knowing where to go when conditions shift. Camels are often associated with sand dunes, but many actually live in rocky deserts, gravel plains, and cold steppes. The image of endless sand does not capture the full range of camel habitats. Their true environment is more varied and complex. The idea that camels belong only to hot, sandy deserts fits dromedaries better than Bactrians. Bactrian camels in particular show how flexible the camel body plan is, handling cold and rough landscapes just as effectively as hot ones. Bactrian camels are desert animals of Central and East Asia, not simply cold weather animals. They live in dry regions where temperatures can vary widely, which requires a different type of resilience compared to purely hot desert species. Camels are often described as desert specialists, but they are really specialists in unpredictability. Their real strength is not just surviving heat or dryness, but handling change. Whether it is temperature swings, food scarcity, or long travel distances, camels are built to cope with variation. Their biology is designed around heat, thirst, tough food, and difficult terrain all at once. This combination of challenges defines their environment, and their bodies reflect that complexity. Camels can handle long-distance movement better than most livestock. This endurance is one of their defining traits. It allows them to travel far without frequent stops, making them essential in regions where distances are large and resources are scattered. That endurance made them especially important before modern roads, engines, and transport systems existed. In earlier times, camels were one of the few reliable ways to move goods and people across dry landscapes. Even in the age of trucks and engines, camels remain useful where roads are poor or fuel is unreliable. Technology does not fully replace them in all situations. In some places, a camel is still the most dependable option. They are especially valuable where animals must feed mostly from open rangeland rather than purchased feed. This makes them well suited to low-input systems where people rely more on natural vegetation than on industrial agriculture. Camels are one of the clearest examples of livestock shaped by both ecology and culture. Their form comes from environmental pressure, but their use and meaning come from human society. This combination makes them deeply significant animals. Their cultural image often emphasizes silence and endurance, but biologically, they are highly specialized and active systems. What seems calm and slow on the outside hides a complex and finely tuned internal structure. The camel's body is full of trade-offs that favor survival under scarcity. It gives up some things, like strict temperature control, in order to gain others, like water conservation. These trade-offs are what make it so well suited to difficult environments. For example, camels tolerate wide temperature swings that many animals cannot. This reduces the need for constant cooling and helps save water. It is a strategic adjustment that supports survival. They also accept lower quality food than many other livestock, allowing them to keep functioning when resources are limited. This flexibility is one of the key reasons they remain productive in harsh conditions. Camels can turn sparse forage into milk, transport, fiber, and offspring, even in difficult environments. This ability to convert limited resources into multiple useful outputs makes them extremely valuable. Very few domesticated animals combine dairy production, transportability, and fiber production as strongly as camels do. Most livestock specialize in one or two roles, but camels cover several at once. Camels show how one animal can be both ordinary in daily life and extraordinary in biology. For herders, they may be part of routine work, yet scientifically they represent a unique example of adaptation. For many herding communities, camels are everyday animals rather than exotic ones. Their presence is normal, and their importance is understood through daily use rather than distant admiration. For scientists, however, camels are models of extreme adaptation. They help researchers understand how life can persist under heat, dehydration, and environmental stress. For archaeologists, camels help explain how trade and movement expanded across dry regions. Their role in history is closely tied to the development of long-distance connections. For conservationists, the wild camel is a warning about how fragile some lineages can become. Even animals that seem common can have rare and threatened wild forms. For economists, camels represent opportunities in milk, fiber, and climate-resilient livestock systems. They are increasingly seen as part of future planning in dry regions. For textile producers, camel hair remains a useful and sometimes premium material. It connects the animal to industries that go far beyond agriculture. For sports organizers, camels are elite racing animals with carefully managed breeding. Their role in sport shows a completely different side of their value. For policymakers, camels are part of discussions about resilience in drylands. They are considered in planning for food systems under changing climate conditions. Camel research today spans archaeology, veterinary science, food science, genetics, and conservation. This wide range of study reflects how important and complex these animals are. The camel's reputation for toughness is well-deserved, but it comes from detailed biological systems rather than simple strength. It is a carefully balanced design. Camels protect their eyes, nose, temperature, circulation, hydration, and movement all at once. Each system supports the others, creating a complete survival strategy. That layered design allows them to live where heat, thirst, dust, and distance all come together. Few animals are as well suited to such a combination of challenges. Their story connects the ancient world and the modern one in a direct way. The same animal that once carried caravans now appears in laboratories and global markets. The camel has moved from trade routes to food standards, from deserts to biotechnology, without losing its original purpose. It continues to adapt alongside human society. Camels are not relics left behind by progress. Instead, they are animals that continue to find new roles as conditions and needs change. At the same time, their oldest value remains unchanged. They help people live in hard places. That simple role is still the foundation of everything else. The partnership between humans and camels is one of the longest and most successful relationships in dryland history. It has lasted because it works. Together, camels and people have built ways of life that can exist in environments many would consider too harsh to support life easily. And as the quiet image of the camel moves slowly across the landscape, it carries not only weight, but a long history of survival, adaptation, and steady resilience, gently continuing, step by step, into the distance.